Energy is a huge field, and I have barely scratched the surface even after 30 years. But hopefully this morning I'll be in a position to share with you uh, in a short period some of the various aspects of energy. The interesting thing is, even without being aware, you and I are constantly spending energy, like 24/7. When you sleep, you have the ceiling fan on, probably air conditioner on, depending on where you live, and you're spending energy. When you get up in the morning, these days, for heaven's sake, there's even a toothbrush that is based on using energy. You know, the alternative that's supposed to clean your teeth, make it cleaner and brighter, that uses energy. You go up down in the morning and get a cup of coffee. You just heated a cup of water. That's using energy. You get on the car and go to your office or go to your business. You're using transportation energy. I mean, no matter what you do, no matter where you go, you and I are constantly using energy, right? So that's the huge challenge. And so the question becomes, we never stop and think about, oh my God, you know, we are using so much energy. How is this energy being produced, and what's the impact of using energy? We don't even think about it. You know, when I was growing up in India a long time ago, we used to have trains, right? You sit in a train, you have a great train ride, and you know, you don't realize that the train those days, all the engines were burning coal. You know, one of the dirtiest fuel that you can find, with no pollution control in the engine, and we would stick our face out of the train and enjoy the breeze, and at the same time inhale a whole bunch of particulate matter that we didn't realize was bad for us. So the challenging thing about the energy industry is that all of us constantly use energy. Uh, of course, fortunately, over a period of time, things have improved, and there is a lot more to accomplish still. And so one of the things I want to talk about is, you know, where the energy is coming from worldwide, you know, US, India, and rest of the world. What are the sources and the importance of renewable energy? Obviously, many of you already realize, and many of you are in that field, so I'm not preaching anything new. But it's kind of mind-boggling to think about what impact we as humans are creating on the environment. So I think it's kind of fits in right with the vision of this organization in terms of sustainability, and you know, what you and I can do, what we can do, what the politicians can do, what the industry can do, what the entrepreneurs can do in the area of energy. So it's a fascinating topic. Before I get on with the rest of the slides, I just want to show you, if you're able to see the cover page, what you see is a photovoltaic system on top of a 3-story parking structure that we designed. This is all probably at least, I'm thinking 10 to 15 years old now. But it just shows you the extent of infrastructure that is required to even make a small project. This project that you're seeing on the screen is probably about a 200 kilowatt project, not big by any means, but it just shows you the extent of infrastructure. You know, we all talk about PV modules and the cost of PV modules, but so by the time you take a photovoltaic panel and make energy out of it, look at the infrastructure. You have these, you know, pedestals. This again, remember, we're in California, so this is California, the earthquake country. So we need to design every structure to withstand earthquakes, right? So there are requirements, code requirements on how these are designed, how these are supported. So, and the other important thing, at least around here, is that visual appeal is very important, right? We can't just, you know, throw a bunch of panels and produce energy. We have to make sure it looks good. So you can see the architectural beams that are attached to the concrete pedestals. The bolts that hold the bolts that hold the architectural steel, there are about 4 bolts holding each. Each of these bolts about an 1.5 inch diameter, 3 feet long, to hold the structure down. And on top of the structure, you see a support frame that is holding an array of about 24 panels along each structure. Now, when you design photovoltaic panels, you need to make sure, at least around here, that you look at the last 100-year wind history to figure out what is the highest wind speed in the region, to make sure that the panels and the support structure can withstand the wind loads, right? Those are very important, because what you don't want to see happen, this is actually a college, you don't want a panel flying off and killing somebody, right? So those are extremely critical things to design for. So each of the panel support structure needs to withstand a wind speed 150 miles per hour. So you can imagine the amount of forces and the amount of complexity it creates in the design of a structure. Then we had to make sure that all the connecting wiring, right, across all the panels are neatly routed through a conduit that goes all the way down 3 stories below through these pedestals, right? So imagine the amount of wiring that is required to make sure that from these panels, the wiring goes to the various combiners that are collecting DC power, which is eventually converted to AC power, right? So there's a tremendous amount of detail that goes into making a project happen. And I think all I wanted to kind of share with you as an idea is, a lot of times we don't realize the extent of work it takes, but every project we take on has to meet a number of criteria, including obviously strength, ability to withstand wind, ability to make sure it looks good. You can see this is probably one of the most beautiful photovoltaic projects that you would see, with the background hill and all that. So, so anyway, I just thought I will give you a sense of truly what it takes. This project, just to give an idea, took about 4 months to design, because every minor detail had to be designed, including the type of board, the size of the boards, the cost estimation of what it's required, cost optimization of how to build it. When this was done, the cost of photovoltaic was pretty high. It was more like $10 per watt. Of course, lately we are seeing prices much lower than that. So anyway, that's kind of a quick introduction on the challenges when we involved in developing energy projects, especially renewable energy projects. So with that, let's kind of dig into some of the big picture items I want to discuss this morning or this evening for you. So the areas I want to talk about are, just give you a sense of the big picture. We definitely want to talk about energy and environment, which are very closely coupled. There is always an impact on environment, no matter what we do. And we just have to figure out what challenges we can take on to make sure that we minimize the impact on the environment. We definitely want to talk about, just compare the different technologies available out there. And the challenge of developing one. So let's say you're an entrepreneur, you want to invest in some projects and make projects happen. What does it take to really get those projects on your portfolio? And finally, we want to talk about, okay, so we have kind of learned or discussed a range of issues. What do you think you and I should be able to focus on going down the road if you're going to be in a responsible position, trying to take leadership position in this field, right? Those are the items we want to talk about. So at a high level, if you look at where energy is going, this is probably very similar to what you see in India. This particular pie chart gives you a sense of where all energy is being used, right? So if you look at least the United States alone, you see the 4 major areas, right? So the first one is a residential, right? We all live in a home, apartment, condo, what have you. So the residential sector is always, a significant sector with numerous appliances, numerous type of air conditioning equipment, numerous types of lighting systems that are constantly using energy, right? Then there's a commercial sector. Well, you and I always go to some office building. Office buildings are expected to be air conditioned, have lighting energy, they have process energy, they have data centers, right? So the commercial energy is a huge segment as well. Then the major other blue area that I show here is the industrial sector. The industrial sector is all the factories. Very likely in India, you'll see industrial sector is probably more than 32%. You'll probably see agriculture as a major sector in India. So between agriculture and industrial, I suspect that the percentage of energy is pretty high. And then, of course, the transportation sector, which is huge, right? So if you look at these major sectors, we are, all of us, from the time we are born to the time we die, we are always depleting energy in all these four areas, right? So in terms of how the world energy outlook looks, you can get a sense of, how the different parts of the world are using energy. Obviously, Asia and Pacific stands out as one of the largest users, as you can see from here over a period of years. North America is number 2 on the list, but it kind of gives a sense of that this is a worldwide issue, not just one country or two countries. It's worldwide as to how the entire world is depending on energy and constantly depleting energy as we speak. So one of the interesting things I found about India, you all probably know, is that we are in India the third largest producer and the third largest consumer. If you look at all countries, that's an amazing. Of course, we have a high population as well, but with all the manufacturing activities, data center activities, building activities, and high population, etc., that I'm not really surprised that we are one of the third largest. We have a capacity of 370 gigawatts in India. And the good thing to know is that apparently the current statistics show that the renewable and hydro combination is pretty significant. 36% is a pretty good number. And it's amazing. I mean, compared to what it was 20 years ago. I suspect 20 years ago, we probably had hydro, but no PV and no wind, 20 years ago. But compared to that, we are significantly better compared to where we were. So it is noted that the agriculture is one of the highest consuming segments within India, which is not surprising because we are primarily an agricultural country in a lot of ways. The unfortunate part is all of us, like worldwide, right? We're still depending on coal, which is, according to the statistics, I believe India's percentage of coal use is 55%, which is pretty comparable to what we see even in the United States. I think the United States is depleting, but 10 years ago, it was probably as high as that. But fortunately, with greater awareness of pollution, greater availability of renewable energy technologies, that number is coming down. But this kind of gives you a sense of how much power is being generated by various types of technologies in India. Wind power is pretty significant. As I recall, I've seen some Indian-made wind power machines, even coming to America. So there's a lot of export activity as well. So between wind and solar power, which are both reasonably economical compared to where they were 5 to 10 years ago, I think we would probably see continued development of wind power and solar power. Biomass is another segment, but one of the challenges, and we'll talk about shortly in the biomass segment, is that anytime we depend on combustion, right? At the moment you depend on combustion, especially when you deal with such as wood or agricultural waste, you're dealing with a very high ash content. When the ash content in a product is very high, when you use biomass for combustion, for example, in a gas fire or a boiler, what happens is that ash is a byproduct, and disposal of ash can be a problem. At least in United States, there are very strict regulations about the potential environmental impact of ash disposal in landfills, because those can be, depending on what you have in the ash, that can lead to groundwater contamination, which is not ideal. Of course, nuclear energy, we all know that we depend on it to some extent, but we also know the perils of nuclear energy. We have heard about the major accidents in the world, one in Russia, and long time ago in the United States as well. So people are generally, at least in the United States, they do not want nuclear power plant in their neighborhood. It's impossible to develop any further nuclear energy in the United States because of the awareness of the potential danger of nuclear radiation that people get exposed to. So I don't think nuclear has too much future, personally, but that's currently there. And very recently in California, one of the largest plants was discontinued, and that trend will continue. So then, of course, natural gas is another major resource. It's cleaner than coal for sure. But one of the problems, one of the challenges in the industry these days is greenhouse gas emissions. And I'm sure you have heard about greenhouse gas emissions. We'll talk about it shortly. So any type of combustion that leads to production of carbon dioxide leads to increase in greenhouse gas emissions, which means that greenhouse gas emissions will trap the heat within the Earth atmosphere and leads to change in global temperatures, global climate change. I'm sure many of you heard about the need for minimizing greenhouse gas emissions, which is a big thing in America currently. In fact, we are working on with various campuses as we speak, trying to figure out strategies on how we can minimize carbon emissions, how we can contribute to the minimization of greenhouse gas emissions. So we just went through very briefly an explanation of these items. How fortunately you can see United States was very high on coal. As recently as 2005, you can see we were peaking at a fairly high value. Unfortunately, as renewables have increased, the coal percentage has continuously gone down. Probably right now it's probably around 25 to 30% at the most, compared to India, which is at 55%. So I just wanted to kind of give you a sense of some of the pollutants we worry about. The problem with combustion of coal is that while we don't see it, we had to worry about sulfur emissions, nitrous oxide emissions, and the most deadly one of all, particulate emissions, which tend to accumulate in the lungs and the breathing passages and cause a lot of other issues. They have technologies in place in the United States that try to mitigate or reduce and control the emissions to some extent. But that depends on what kind of controls you have, like electrostatic precipitators, bag houses to capture particulate matter, scrubbers to make sure that the emissions coming out of the plant is reduced, is cleaned up for the sulfur dioxide emissions and so on. So this particular chart shows you an extent of various control measures in place at various coal plant locations in the United States. Unfortunately, these are expensive technologies, right? Anytime you take an old plant and try to convert and add on retrofit measures, it's an expensive process. And it is a bit sad that India has not been able to implement. It is my understanding, based on what we read, that there are a lot of plants that are still without those kinds of controls. And there have been numerous studies that point to the industry and say, look, there are people, health getting affected, impact, implement those measures and so on. But it takes time and money and investment. But that's an issue we all face. The moment you have a coal combustion device, fortunately, the trains these days, they don't have any coal, I hope. It's mostly diesel engines, but which is not exactly perfect, but still it's probably a shade better than coal. So there are some serious environmental impacts. What I want to kind of share with you very briefly before I jump onto the renewable is that some of the criteria of pollutants, right? So when we talk about energy production in the United States, I'm sure it's all over the world, there are 5 or 6 criteria pollutants which are always monitored, because when you decide to put in a new power plant or a new combustion device, even in if it's a small college that uses let's say a boiler for heating hot water, we need to go through the permitting to make sure that they comply, right? So what are the major criteria pollutants that you see? And certainly many of you might have heard about this. Ozone, right? Ozone is one of the first one on the list. We had to worry about ozone at high levels as well as low levels. Each of them have a certain impact on the overall environmental health of the population with the surveys. The next major pollutant is sulfur dioxide. We talked about the impact of coal combustion, right? Any fuel that has got sulfur, including diesel, some of the petroleum oils, fuel oils, and coal especially, have sulfur content. So sulfur content in excess has got huge impact on human health. The next major pollutant is particulate matter. We talked about particulate matter. The control technology for that is bag houses, electrostatic precipitators. A lot of times when you drive by on any Indian road, freeway, you'll see on the side people burning, husks and waste and all that. You look at the dark smoke and the carbon and soot and everything else. You don't see the particulate matter, but anytime you see those kinds of combustion going on, whether it's even fireplace at home, you are potentially exposed to particulate matter, which is unfortunate. But and there are different grades. When they say PM10, they talk about particulate matter, which is around 10 microns. PM2.5 is particulate matter that's 2.5 microns. So they have various ways of categorizing particulate matter so that the technologies for controlling them can be designed for capturing those particulate matter. Carbon monoxide, of course, everybody knows the danger of carbon monoxide. Very often you hear stories about how people went to the garage, closed the garage door, left the car running, they got on the cell phone, kept talking. They didn't realize how the carbon monoxide level in the garage built up and they died. So, I mean, so you hear some stories of that nature. So carbon monoxide is a nasty component that can kill without persons being aware of it. We hear a lot of stories, especially in American East Coast cities where we have in-house furnaces, right? Because the temperatures in East Coast, we're dealing with, -10, -20 degrees sometimes in extreme climate. And a lot of the homes are designed furnaces inside the occupied area. And if those furnaces misbehave and if they're not checked frequently or cleaned, and if they have a bad flame, we have heard stories about how carbon monoxide emissions from that furnace can kill people, right? So there's some numerous dangers that we encounter daily in our life. So we need to be watchful of, what those are. Nitrous oxide is a big deal, right? Obviously, leads to smog and respiratory problems and all that. So anytime we do a project here, we have to demonstrate that whether it's a boiler, whether it's an engine, whether it's a reciprocating engine, or whether it's a 25 megawatt gas turbine engine, we have to go through air quality permit districts to make sure that we have in place mechanisms to control the emissions within a certain limit, right? So those are all very tightly controlled. We cannot do a project in most of the United States without tight justification that we have done a good job in controlling the emissions to what is known as best available control technology. It's called BACT. So, and the BACT continuously changes depending on what happens in the industry. They continuously tighten the grip on what the latest emission control technology should be for a project to be permitted. So it's a constant battle. It's one of the biggest battles every project developer goes through, rightly so, when it comes to developing a project. And I hope there is an equivalent system in India, but I'm not sure. I've been out of the loop. So the last criteria pollutant we're talking about is lead, which is the 6th largest thing to worry about in terms of criteria pollutants. A project developer, when he's proposing a project or building a project, has to go through a permitting agency to make sure that the best available control technology is used for regulating and controlling the emissions, which is a very important part of the process. And I just mentioned that I've been out of the loop from Indian permitting, so I quite don't know what process you have to go through, but hopefully there is something good that ensures that people like you and me are protected from polluting sources. All right, so before we jump on to the specific renewable technologies, the one thing I wanted to mention, I talked about greenhouse gas emissions, right? So the big deal right now in every I would say 80% of the American institutions, especially like colleges, universities, large universities, is that how do we operate buildings and systems to minimize greenhouse gas emissions? That's a really big thing in America right now, because we all realize that we as a society need to do better to make sure that there is no global warming. And we need to make sure that we leverage the current available technology in renewable energy and try to minimize the carbon emissions, right? Which is part of the global concern on greenhouse gas emissions. So, so if you look at the major components of the greenhouse gas emissions, obviously carbon dioxide, right? That comes from the combustion source, which whether it's coal or natural gas or biogas, I mean, we always have carbon dioxide emission. We have refrigeration, right? We have chillers that produce air conditioning. The chillers have refrigerant that cause impact on the environment, that's why they're categorized as part of the carbon, with the greenhouse gas emission. Then we have methane from landfill, right? That is another, as we all consumers, especially in America, we produce tremendous amount of waste, right? Huge amount of waste, which all goes into landfill eventually. And the landfills have methane contribution. Fortunately, in many parts of the country, we have installed burners to burn natural methane that is produced in the landfill to produce power. Right? So there are some places where landfill gas has been used effectively, but there's still, so long as we humans create a tremendous amount of waste, unfortunately, we continue to contribute to methane. And of course, nitrous oxide is also part of the greenhouse gas emission. So now let's talk about how the photovoltaic industry has changed over many years. I started consulting in 1990. Those days, in fact, when I came to the United States in 1981, there was probably a single company, one company in the entire country that was producing small size panels. I'm talking about, when I say small, I'm talking about 50 watt, right? Think of a 2 feet by 4 feet panel, we're producing 50 or 60 watt those days. And it was costing a horrendous amount of dollars. So people said, forget it. We don't have time and money to invest on a panel that costs you 10 times more energy than what we're paying. And that was the era in 1980 when I came to this country. But look how much the industry has transformed over the last 40 years. So the serious production of the panel probably started in the late 90s, and you can see the gradual depletion in overall cost compared to where we were. And today, I believe some of the largest photovoltaic projects, they are priced at $2. $2 per watt compared to what it was. So, thanks to the Chinese panels, there are a tremendous amount of production coming out of China. As far as the consumer is concerned, the price of energy has substantially dropped. I'm sure it's the same in India as well, that you're able to enjoy better prices compared to what it was. So one of the challenges that we wanted to talk about was, what is it? I gave you a sense of all the infrastructure that goes into making a PV system happen, right? So if you start thinking about the various ranges of PV available, you can have PV at your home, you can have PV in an office building, you can have PV in a parking structure, you can have a ground-mounted PV somewhere far away from the communities. So there are many different locations where you can install photovoltaic. So the challenge is, what are the downside of installing PV, right? What does it take to really maintain them? Of course, a lot of times we put it on top of a roof of a house or an apartment complex, and we expect things to work, right? But things do require maintenance, right? So I just try to identify here what are the typical usual thing that we have to deal with, right? First of all, you have PV modules, right? So the PV modules, over a period of time, depending on where you live, depending on how much dust accumulates on it, it has to be constantly cleaned, right? If you forget about it, a lot of times, and we get a call from a client saying that, hey, Chet, can you come and check out why our PV system is not producing? You go there and look at plant weed growth, and you have things sitting on it. You have bird droppings, nobody cleaned. So unless you maintain the system, you cannot expect power out of it. And the other interesting thing is, the PV systems are wired in series. So for example, if each panel produces about, let's say, 40 volts, you have about 12 panels producing 480 volts, because you need to get some minimum power threshold before you convert that from DC to AC. So if multiple panels get killed, you don't get the right voltage. That series circuit automatically gets killed. So you lose the power production pertaining to those entire series, right? So that's one of the important components of maintaining a PV system, that you can't just install and forget about and expect revenues to accumulate, but you need to maintain, keep an eye on, are they performing. Even the best of the panels, over a period of time, you have degradation. So typically you would expect, over a period of, let's say, 20 to 30 years, you would expect minimum 10 to 15% degradation. It depends on how well it's maintained, but over a period of time, PV cells degrade. And the other interesting thing that happens is, technology is constantly changing, right? So a typical panel 10 years ago would be available for, let's say, 140 watts. Today, in that same size range, you can get a panel that can produce over 300 to 400 watt, depending on which manufacturer you pick with. So the intensity of collection is gradually improving. Efficiency is also improving, but there are some, obviously limitations of the technology. Then what else do you need to maintain? You have, in a typical PV installation, you have a fuse typically with, every series circuit, because, you need to protect the people who will be maintaining it, and you want to make sure that there are no overcurrent. So you need to maintain space, which is not a big deal. That's easy to do. Then you have combiners. Combiners means you're taking power from multiple series circuits and combining them into a single circuit that can produce 480 volts or 600 volts or 1,000 volts. So those are, anytime you deal with high DC, you're dealing with potential arcing. So you need to make sure that those combiners and disconnects are well maintained, because that's a safety issue. And there are some strict regulations on where to place those, how to design those disconnects, how to make sure they're safe. And because there's any interruption of utility power, there are requirements on how to isolate the PV from the rest of the system. Because what you don't want to see happen is, you don't want a system to create a potential risk of a shock to another consumer. So let's see. Then we have inverters. So inverters are the devices that convert from DC to AC, because ultimately we need power to the grid in AC. So the most complicated system part of the PV is these inverters. Unfortunately, there are quite a few manufacturers available on inverter, but they depend on electronics. So the electronics need to be maintained at a certain temperature. So a lot of times, depending on where you place them, whether it's exposed to heat or whether it's exposed to weather, these are the components that can potentially fail. But it's not a big deal. I mean, there's enough technology available, and over a period of time, I've seen new inverter manufacturers come along, and with the competition, they go broke, they get absorbed. So it's a constantly moving field with new players in the market, and there are some major players in the market. So the technology of conversion is pretty solid. Then there is data acquisition and metering, right? So ideally, you need to know how much power is being produced by your PV system. So it's always nice to keep track of what you're producing and how much you're producing, and whether your production is commensurate with the solar radiation that is coming in constantly, right? So the reason I wanted to kind of show you these components was that there's often a myth that, oh, okay, I got installed my PE, I'm done, right? So you're never really done. You got to keep an eye on making sure that these components are working optimally and working correctly to get you the power that you need on an ongoing basis. Very often, these are neglected, especially when you have panels on the roof. And how many times do you see people going up on the roof of a building, which is not easy, right? It's always a safety issue when you try to go on the roof. So when you install panels on a roof, there are strict regulations here in California, and I'm sure around the country, and I hope it is in India as well, is that you need to maintain certain distances from the edge of the roof so that people can walk around, they can access, they can maintain. And the other important thing is, you want to make sure that when you lay out the panels, you lay it out in such a way that one array of panel does not cause shadow over the next adjacent area, right? Those are easily missed. A lot of times people want to maximize application of PV, and they try to shorten the distance between rows of panel, with the result when one panel is against another panel, it casts shadow on the other one. So it should be really separate so that shadow can be avoided, right? So the simple things to watch out for, but you'll be surprised at how many situations there's negligence in sizing and also in laying out the panel. There are very strict regulations about how to size the PV, because remember, the amount of PV production is a function of many things, not just solar radiation, but it's a function of the temperature. There is what is known as open circuit voltages, there is short circuit current. So every detail needs to be examined to make sure that the way the wiring is sized, the way the panels are designed, the way the series string is designed, all of those factors are examined to make sure that the system is safe and performs under a range of weather conditions. Because when you look at the range of weather condition, you look at the coldest temperature at which you have a certain production. And you also look at the highest temperature at which you have a different voltage. So the performance of the panel has to be examined at extreme temperature conditions at that location, which is important. So let's move on to the next topic, right? So now we have a sense of the PV in terms of what it takes to design, what it takes to maintain. Looks easy, but there is a lot of little details one has to watch out for. Now let's look at the wind turbine. Now, the fascinating thing about the wind turbine is that I would say, when I came to California, I would say in 1982, right? We used to see one single turbine made by Boeing. That was like 1 megawatt. And every time we went by the freeway, this was on the way from Sacramento to San Francisco, we used to see the turbine, but I never saw it running. It had a whole bunch of problems. And that was, infancy, right? But Boeing took the lead at that time to, come up with a turbine concept, which probably hardly ran. But look at the fascinating thing that has happened over the years is that today, it's a common thing to see, in many parts of the world, turbines that are rated for 1 megawatt up to 3 megawatt, 4 megawatt, huge turbines. We're talking 200 meters blade, 180-meter blades. But the challenge is, there are many challenges, but let's kind of go through in a simple wind turbine component, right? What it takes to maintain a wind turbine. You got the blades. These blades are ridiculously long. I mean, but it's a challenge to transport the blades. You have got bearings that allow for the rotation. If you look at a typical wind turbine, you could be looking at 120 miles per hour tip speed when the wind speed is 12 to 15 miles per hour. So you got, huge, distances, speeds to deal with. And look at the amount of design engineering and it takes to design a blade that can run at that speed. Look at the amount of centrifugal force that is involved, the mechanism that is involved in building a very tall support structure to support the whole rotating component. And the other important thing is the system has to yaw depending on the wind direction so that the power production from the wind is maximized, right? You don't want to have a static situation and the wind blowing across in a very non-optimal way. So you got to have a yaw mechanism so that the wind turbine can align itself to the wind direction. The moment you have a change in speed, because the wind turbine will be rotating at less certain RPM, but in order to produce the power that you need the generator to be operating at different RPM. So you have a gearbox in the middle, so that has to be maintained. Brake system is important. Why? Because sometimes we don't control the wind speed. Sometimes wind speed can be excessive. So you don't want to, your wind turbine will be designed for a certain speed limit. And in the event that the wind speed exceeds a certain limit, you want to make sure that the wind turbine is not destroyed or cause potential damage by falling down or hurting other adjacent property. So that's important. Lubrication system is important. We talked about the yaw, bearing, and gear and mechanism. The hydraulic system associated with all the controls is important. And finally, instrumentation like wind sensors, anemometer. But the biggest challenge of all is how do you maintain the thing? When this thing is about 300 feet tall or 300 meters tall, how do you get to it, right? So there are strict regulations on safety again here when it comes to turbine maintenance. In order to maintain any component, I mean, you have to literally climb a tall tower inside with safety harnesses and so on and so forth. It's a specialty field definitely by itself. And so it is not, unfortunately, yes, you can find smaller turbines. You probably even have seen small turbine that can be mounted on a house producing a small amount of power, but the amount of maintenance it takes is quite intensive. And whether it's both wind energy or solar energy, we are a little bit at a loss in the sense that if you put a conventional gas turbine, right? When you put let's say a 1 megawatt gas turbine as an example, or a 1 megawatt conventional power plant, you can expect to see that 1 megawatt production constantly 87, 60 hours a year, right? Constantly, because so long as you keep it running and so long as the fuel source for it, you'll keep running. But wind energy and solar energy very different, right? Typically what happens is solar energy, right? When you put in 1 megawatt of solar, it does not mean you get 1 megawatt constantly, right? You only get it when there is sunshine, and the sunshine varies from day to day, season to season. So typically a rule of thumb is 1 kW of energy, roughly speaking, depending on, it varies from where you are, is about 1500 kilowatt hours. right? As opposed to 87, 60. So the average utilization of average capacity factor, as you call it, is very small. Same thing with wind, right? So, although you might say that, there is wind blowing, wind blows over a certain period of small portion of the day. So the success in installing and selecting sites, whether it's PV or wind, depends on what the regional characteristics of energy is in that area, how often the wind blows, how much does it blow, what direction does it blow. All these are important. So when a developer takes on a study to find out, is this a good location? I remember those days when in the 80s, 90s, we used to run around different sites in California, try to put wind anemometers to figure out, okay, let's study the wind speed here. So anyway, I hope that gives you a sense of the challenges involved in either selecting PV or wind. The main thing you want to know are these technologies do exist. They have matured a lot, but we can never take it for granted. There are tons of things to maintain, tons of things to work on. Nothing is bulletproof, right? One thing we also want to talk about, so over a period of time, you also heard about offshore wind and onshore wind, both are available currently. But the good news you can see, if you look at the, what I tried to show here is that the cost of dollars per kilowatt has gradually come down, depending on where you are, which is good news. Typically a power plant in conventional power, a typical rule of thumb is about $1,000 per kilowatt, typical, right? Conventional power. But the fact that the PV and wind are currently available about around $2,000 per kilowatt is a pretty good, step in terms of making renewable energy more affordable. Hopefully with time, they'll go down further, but that'll help. Let's talk about some of the impact on the environment, right? So like I said, everything has an impact on the environment. No matter what we do, we can't run away from it. Biggest impact of wind energy are two things. One is impact on bird life and bat life, because birds and bats, they fly in massive swarms, and potentially there's a big concern about impacting the endangering those species. And the second big impact is noise. That's a huge issue, because when people, developers cite wind energy, especially large ones, very close to communities, that's a problem. So typically a wind turbine system can be producing at very close to, very next to it, almost as much as 100 dB, right? As you step away from it, obviously the sound level decreases. Typical comfort level for noise can be as low as 30 to 35 dB. Sleeping noise should be around 30 to 35 dB or lower. But the moment it goes beyond 40 dB higher, then people have issues, right? So that's something to be very concerned about in terms of how you locate wind turbines if you go with those kinds of technologies. The challenge with PV, sorry for the long write-up here, but this is something that you can use as a reference if you're interested. There's a tremendous amount of manufacturing process involved in PV, right? You have various kinds of acids, processes. So all those have to be disposed of in some way, some reasonable way. And some of them are hazardous. Obviously, when you're dealing with hydrofluoride, hydrochloric acid during the manufacturing process, we're dealing with some dangers of disposal. So we need to worry about how to safely dispose of the hazardous materials that are created and are used during the manufacture of the PV cells. So those cannot be ignored. Now, once the PV life is over, right? Let's say after 30 years, you decided to dismantle PV. How do you dispose it off, right? Now, if you look at the PV component, a PV component has glass, it's got aluminum frame, it's got plastic, it's got silicon, right? Everything has got to be disposed of. So how do you do that? So you can't just go and dump the whole thing in a landfill. You need to have recycling plants. Now, worldwide, right? Worldwide, across the world, we are now using PV panels in our homes and buildings. But I think there are some companies are coming up lately thinking about recycling. And there are plants now being created to help with taking down an old PV panel, breaking it down into recyclable materials to help minimize the impact on the environment, right? The so so in terms of the downside of any of these technologies, right, there's always a downside. You can never get away from it. What we need to be watchful for and plan for is to develop the industry in such a way that when there is a need to dispose of these panels, there are factories available, there are plants available that can safely break these down into components that can be safely disposed of, right? So that's kind of here's an example of, the, the issue I talked about in terms of the quantity of waste that is created and what we have to watch for. And as we increase our PV production, our next generation, our children, our grandchildren, that generation will have to, deal with potential disposal issues. So it's very important that we not forget our obligation in terms of planning for that scenario. So hydro, right? You think, obviously you've seen hydro energy as well, and there are very large plants with using hydro energy. And the biggest downside of this hydro is the impact on fish and game, right? I mean, one of the state departments in California there's a department called Fish and Game. So their only job is to make sure that these hydro projects do not are situated in such a way that they do not impact aquatic life, right? That's very important. Um, so, so it's kind of comes back to what I was saying, that no matter what you do, we humans are well known for creating an impact. We just have to figure out, is there a process available? Is there a permitting process in place? Is there a regulatory process in place? Is there somebody policing you to make sure that you do the right thing and not rampantly impact the environment? And of course, hydropower, like anything else, you had to think about where the opportunities are, where there is enough water head available, where there is a natural dam available, or possibility to collect the potential energy that water has and convert that into power energy. And the challenge is doing it in a safe way, right? So one technology that is quite popular, very expensive, unfortunately, is the fuel cell energy, right? So fuel cell energy is basically you're taking gas like methane or natural gas, and you're breaking down into carbon dioxide and hydrogen and all that, and you allow hydrogen to mix with oxygen, it produces power. So the power efficiency of the fuel cell can be as high as about 40-45%, which is very good compared to a combined cycle, gas turbine combined cycle plant, which is probably around 37%. So we can get about 45 to 50% of just the power efficiency. Now, on top of that, if you're able to recover the heat, another, say, 30% to 40%, so potentially you can achieve an 80% efficiency in a fuel cell. But unfortunately, the cost of this, remember I mentioned about $1,000 per kilowatt is kind of the standard default for conventional power. So these can be expensive. This can be $3,000 to $4,000 per kilowatt. So with the result, although we have installed these in some of the campuses, one of the first projects we worked on was a project here in Cal State Northridge. They installed, the same company installed, I believe, 1.5 megawatt fuel cell, if I recall correctly. It takes good amount of money and investment, but it's interesting technology compared to the convention. So does it take more maintenance and more cost than PV? Yes. So for the same reason, unfortunately, I think when customers have chosen fuel cell, it is mainly because they wanted to use both power and heat together, as opposed to just power alone. So just to summarize what we talked about on the renewable energy, one of the things I'll tell you shortly is that although you and I can put in PV panels in our homes, which is not a big deal, right? We have a small power, but when you start thinking as a developer who wants to develop large projects, photovoltaic projects, or wind energy projects, you have to think about the transmission infrastructure, right? So the transmission infrastructure is existing. Utilities own it, at least in the United States. You have various public utilities. You have utility investors who have currently, funded the utilities to provide large transmission infrastructure. So if I have a transmission infrastructure that can only support 50 megawatt, let's say the wire size of the, that pole that go across the hill mountains is about 50 megawatt, and I'm a wind developer, I'm coming and say, okay, I want to put in a 100 megawatt turbine. How in this world is going to happen, right? So you need to make sure that when you select a site, you consider the available limitation of the transmission infrastructure so that the power you produce can be effectively transmitted from point A to point B. So it's a huge limitation. One of the biggest challenges worldwide, especially in the United States, is we have huge bottlenecks. Although we have a very wide transmission network, I'm sure the same thing applies to India as well, is that these are old infrastructure. It takes billions of dollars to refurbish them. So you might see a phenomenal potential of PV or wind energy somewhere, but it's impractical to deploy it unless the utilities invest in upgrading the transmission infrastructure to bring the power from point A to point B. That's very important. So the next thing I wanted to mention to you is generation profile and demand profile need to match, right? So let's say that your demand in a given area is only 20 megawatt, and you want to identify potential 100 megawatt. So what does that mean? That means, sure, you can certainly feed the local community with 20 megawatt, but how are you going to deliver the remaining 80 megawatt, and where are you going to deliver it, right? So when you start thinking about large power generation sources, it is very important to think about and understand what the demand profile is in a given location, and whether your generation profile, given the dynamics of when you get the wind power, when you get sun power, etc., matches what you're really going to produce. Incentives, very important, right? So given that there's always a challenge in producing renewable power, whether it's a transmission bottleneck, whether it's a technology bottleneck, one of the good things that has happened in the United States, and I hope you have a similar situation in India, is that there's always incentive. One of the reasons the photovoltaic industry took off was that for a long period, I'm thinking almost for a 10-year period, the utilities were made to provide incentives, that's called self-generation incentives, so that developers can make use of the incentives to build those projects. Fortunately, we are in a place in the United States where incentives have been provided for photovoltaic, wind energy, and so on. So the next thing I want to talk to you about is energy storage. PV is a good example, right? So we have, let's say, a photovoltaic project that produces power during daytime, right? And a lot of times your demand is not there on weekends. A good example, right? I might have a weekend, high day demand on a weekday, but Sunday and Saturday I may not have demand because the business is closed. So how I'm going to do the store the energy, right? Or if I want to just shave off peak demand, let's say, typically in most utilities, right, the peak period is always the most expensive period, whether it occurs at late afternoon or evening is always the most expensive period. So we have battery storage technology currently. This is one of the, what you show here in the picture is a campus I work with. It's called the Cal State University, Dominguez Hill, where they installed a 4 megawatt hour battery system that basically, think of it as the Tesla batteries package. In fact, yeah, it's actually a Tesla battery pack. Each compartment holds a whole bunch of batteries that are cooled, roughly about 20 feet long by, say, about 12 feet wide, roughly speaking, container that can produce about 4 megawatt hour. Now you will see, obviously battery technology is also new, right? It's kind of gaining popularity slowly for two reasons. Number one, of course, is the ability to store energy in an efficient way and use it when you need it. And the second thing is it is actually helping peak demand shaving, right? In a microgrid climate, where let's say there's an interruption to utility, there's a storm, there's a fire, and California is known for fire, especially in Southern California, Northern California, in some locations. Let's say there's a complete disruption of utility. One of the good things about the battery storage and photovoltaic is that you can have a completely self-sustained community, whether it's a college, whether it's a community, which has PV, which has an emergency generator set if needed, which has battery storage and controllers to automatically manage the production and generation in a way. In other words, if your demand can be spiking, but with the battery, we can actually use it and discharge the battery when we need it. So battery technology is one of the newest things that are coming along in the industry, where where we can actually make use of it. And it applies to honestly both residential and commercial. I know that there are many homes and apartments in India, already using battery, but this is a little more advanced, bit more efficient battery system where you can use your PV energy generation, store it, and use it when you need it. So just like we have storage for electricity, we also have storage for other things, like chilled water is a good example, right? I mean, you and I probably work in office buildings that are typically air conditioned. And generally speaking, during daytime when it's hot, that's when you don't want the equipment to run because there's already enough demand on the utility. Of course, these days we have PV power, but 10 years ago, we didn't have photovoltaic power, right? So how do you avoid running air conditioners during daytime? So what we do is we actually have cooling devices that run at nighttime, store cold water, chill water, we call it, at let's say 39 degrees, 40 degrees temperature in a storage tank. These storage tanks can be 100 feet tall by 80 feet diameter. Think of it like a large building, but except it looks like a big tank. So we can store the energy in this storage tank and draw it during daytime to cool the building. So that's a pretty common thing that we see. In fact, I'm working with about, CSU, California State University System, which is one of the largest university system in the world. So literally every campus within the California State University system uses this technology for minimizing daytime demand. And also, when we run the chillers at nighttime, we actually use less energy because the nighttime temperatures are lower for the wet bulb. That makes the heat dissipation a lot easier from the cooling towers. So that's the technology that we use to help overall reduction in managing overall energy resources. Now let's kind of step back, and now you heard about, me talk about the various aspects of the industry, and let's say that you're an aspiring developer, entrepreneur who wants to develop, renewable energy, whether it's PV or wind energy. Just think about some of the challenges and the players that are involved in this development, right? So let's assume for a moment that you're a developer. You are the man, you're the lead when you're the developer, and because you need to bring all the parties together to make things happen, right? So one of the biggest things is you got to deal with permitting, right? So when you decide to build a project, you need to worry about, is there transmission capacity? Is it permittable? You need to deal with public utilities. That gives you, okay, what kind of a relationship am I going to have? What kind of interconnection agreement do I need to have in order for my project to connect with the existing utility? But because ultimately, you're not going to build brand new transmission lines. You need to depend on the utility to provide your transmission line. So there are strict requirements on how a project should be tied to the utility. There are strict requirements about how a project will impact the environment, whether it's hydro energy, whether it's wind power. There's always a permitting issue. Now, the reason that's important is that, I'll get to that shortly, is that when you think of a global scale, when you think of the entire nation's transmission system or a state's transmission system, it's a very complicated system because that system consists of existing power plants. These can be large power plants. There can be 50 megawatt, 100 megawatt, 200 megawatt plants that are expected to meet the consumer demand at all times. So the utilities are required to provide the required capacity to every consumer, right? At the same time, we small developers are coming up with numerous projects, whether it's in a home, whether it's businesses. So these projects are completely out of my control as a utility manager, right? The projects being developed left and right. Each project has its own characteristics. Each project has its own maintenance. And I'm expected, to maintain supply to the community of this, whole city with all this juggling, all this resources. So it's very important for the utility to do power flow studies to understand how the existing large plants can turn on, modulate, and control matching. Because ultimately, if your demand is 100, you can't be pumping 200, right? Because there's not enough battery storage capacity available, to absorb any level of inefficiency. So transmission planning, generation planning, permitting is a very important process to help have a stable power flow infrastructure. So one of the biggest things that happens is when you're a developer and you approach a permitting entity. In California, there is a power siting division that looks like this whole big picture of the entire transmission grid within the state to understand where you can actually provide the power, what is the dynamics, how will it impact the rest of the existing infrastructure. Because what you don't want to see happen is, somebody putting a plant that causes total instability in the power flow dynamics. So it's a critical component of evaluation of a power plant, whether it's wind energy, solar energy, or even traditional energy. The next challenge as a developer is you got to prove to your investors that the money you get back from selling energy is adequate to pay for your debt, right? If you're investing in a $100 million project, how are you going to prove to the investor that you have deals in place with the power sales that are possible to produce the amount of revenues that are make up, right? I mean, for example, PB, right? If I'm paying, let's say 10 cents now, why should I, as a consumer, pay 15 cents just because you're investing in a project, right? I will continue to pay 10 cents, right? So those dynamics need to be considered into the equation. Usually what happens is, in the reality of life is, in like California or United States, if I'm a developer, I cannot go and deal with a million customers, right? I would go and make a deal with the utility that is, whether it's Southern California Edison, PG&E. So I'll usually have a power sale agreement that says, look, I'm producing X amount of power, and I'll contract with you, Mr. Utility, to buy this power at a certain rate. So, and that has to be attractive enough based on all the investment I'm making to make sure I can convince the investor that this is a reasonable proposition, right? So challenge for an entrepreneur developer is huge, because you got to deal with the permitting, you got to deal with the finances, you got to satisfy the investors. Then you have to deal with the design time. Once all that is done, right? Once you put this whole thing together, then you're in a position to say, okay, now I'm ready for actual implementation. I've got a reasonable deal together. I got permitting in place. Now I'm going to deal with the design team that designs the project well. I'll deal with the right manufacturers that provide me reliable product. I'll deal with the right installation company that can build this product well, and have a maintenance contract in place that can maintain this project well. So all these pieces have to be assembled. So just to give an idea, one of the first things, responsibility I had when I came to California was, so I spent about 5 years. At that time, the state had a goal of developing 400 megawatts of power. And those days, the technology was cogeneration. Cogeneration means a generation you produce power and you also produce heat, because every building in the country, it requires both heating and cooling. So cogeneration concept came about to help get away from the just traditional power and traditional heat, but combine the two in one project called cogeneration. So a 25 megawatt project, one of the first projects that I was working on was at UC Berkeley. That is a 25 megawatt project. That campus had traditional boilers and traditional power, getting power from PG&E. So during a short era between, I would say, 80 and 85, the utilities offered what is known as a standard offer, which is a very attractive rate to provide incentive for producing power. So the projects got developed for, if like a campus like UC Berkeley, the project we developed was about a 25 megawatt project. It's still in operation, by the way, working well after 30 years. And then I came to UCLA, then, because I had that expertise in developing these projects. So UCLA at that time was in the process of looking for a very large central plant that produces heating, cooling, power. And so we had ended up developing a 42 megawatt those days. But every one of those projects literally went through these processes, permitting, big deal. Like those days, because the air quality is a huge thing in California, and the permitting agents are extremely stringent about allowing for plant that, to make sure the plant produce least amount of nitrous oxide emission, the criteria pollutants we talked about. But that concept is typical in all projects. What an investor or what a developer goes through, putting the pieces together. It takes a huge amount of energy, huge amount of entrepreneurship, dedication, and challenge to make things happen. I mean, it's not easy to develop a project because of the various pieces, various agencies that are involved. But it's something that people have done. People have made tons of money on it. My ex-boss, ended up developing wind farms. So, he's today in the business, providing, developing resources, wind generation resources all over the world, actually. So ultimately, we all cater to one entity, consumer, they demand, they pretty much dictate what the price is, right? Ultimately, you as the developer, you maybe sell to the utility, but the utility has to satisfy the consumer, right? So ultimately, what the consumer pays governs, the whole thing. But it takes a huge amount of effort to put all these pieces together. So just to illustrate the challenge of what we see, I talked about demand, diversity, and all that. This is a real screenshot of the way the power demand goes in California. This is the entire system-wide demand as we speak, and we have the ability here. I hope there is similar ability in India as well, where you can look at how the electric demand statewide. This is, for example, right now, nighttime. This was on a Monday, June 15th, I believe, is a Monday. So you can see the nighttime demand was right now about hit a low of about 18 to 20 megawatt. But the interesting thing is that you can see the demand on the system peaked at 6 p.m., not daytime. I'll tell you why shortly. But you can see the demand peaked at 6 p.m. and people go home, start, their lights on and their cooking on or what have you. So it peaks around 6 p.m. Now, if you look at the next slide, you'll understand why the demand is low during daytime. You can see the PV production. So PV is producing almost like 10 to 11 megawatt, right? In California, this is California total production. You can see that the production starts around 7 a.m. It goes up, it reaches a high of about 11 megawatt. And for the same reason, you'll see in the slide that I just presented previously, you see the demand, the system demand is low because a lot of homes are producing PV power, installations are producing PV power. So this is called the duck curve, which is a famous duck curve, because that's a challenge the utility faces. That historically the peak used to be during daytime, right around 12 o'clock, 1 o'clock, 2 o'clock. That is the typical time when the air conditioners are blazing, heat is on, cooling is on, lights are on, offices are on. And that has gradually now shifted to late evening, right? So this is called as a duck curve in United States. And like I said, it's a challenge because the utilities have a job to do. Because they have to meet the demand of the ultimate consumer, like you and I. And you have all these power production devices coming on. And so it's a huge challenge balancing it. But having real-time data helps. So we have systems in place where we can literally see current demand statewide so that generation resources can be planned accordingly. So we talked very briefly about the power grid. This shows you the power grid infrastructure in United States. This shows the various transmission lines at various capacities. And so it is important so imagine the complexity of the modeling that is involved in simulating the impact of new power resources, whether it's wind energy or solar energy. Every one of these will feed existing transmission lines. So we need to make sure from a development standpoint that there is a match between transmission availability as well as the location of where you generate. Now, I was trying to see whether a similar map is available in India, but I think the best I could get was, for this presentation, a regional map that shows the 5 major geographical boundaries of India's power grid. It's kind of interesting that I'm sure there are many engineers working on those kinds of things, which are, to help the consumers see the dynamics of real power flow. But that's always a interesting challenge. To simulate power flow is a huge challenge, and you'll see many electrical engineers, PhDs, working on understanding how well the entire nation's system of power flow can be controlled as people bring on more and more renewable energy. So as a consumer, we may think of renewable energy in a very small, discrete segment, like rooftop or whatever, but you have to step back and look at the bigger scale and understand the complexity of dealing with it at a national level, a regional level. So one thing, as one of the last slides I have today, is almost, I think, slide 37, is that you got a glimpse of the big picture, right? I mean, we looked at how we're all using energy. You looked at the various energy sources. We looked at the potential technologies. We tried to understand and discuss the challenges with each technology. I also gave you a perspective of what a developer goes through to develop a technology. If you look at all that, I mean, we just pause for a moment and think, right? The best thing you and I can do, the best thing we all can do, is to reduce our dependence on energy, right? Reduce. That's the key thing. Conservation. We cannot ever overstate the importance of that, right? It's a vital component of our, should be a vital component of our life. Because if you conserve, if you place less demand, there is obviously less demand on generating sources, right? So what can all of us do, you and I do, is as we think through every aspect of our daily life, conservation becomes a key component. So whether you're designing a building or living in a building or using a building, whether it's a home or a commercial building, there are always opportunities for making things more efficient. In fact, in California, there is a organization called California Energy Commission. So they produce standards that buildings must adhere to for California. And gradually, every 2 years or 3 years, the standards are tightened further to make sure that every new building or every major renovation, whether it's a residential sector or commercial sector or industrial sector, they go through a tight process of permitting where buildings are approved for construction based on meeting those standards. So that's very important. For example, 15 years ago, the lighting standard were based on, let's say, use of T8 light. Gradually, with LED lights being available, today every building, new building that is being designed goes with LED technology, right? I mean, we're saving tremendous amount of energy in using LED technology. 20 years ago, 30 years ago, I used to work in factories in India. Actually, my first job out of when I finished my graduation at IIT Kharagpur was a job in Britannia Industries, right? And I used to see those locations with pretty much constant speed motors, right? Motors running with constant speed. But today, I hope a lot of the factories are transformed into variable frequency drives where the motor speed is reduced for helping, reduce the energy use, right? So likewise, appliances, right? I'm sure we all deal with appliances regularly. The most common appliance we all deal with is refrigerators, right? The technology in refrigerators have improved a lot. The efficiency used to be very bad, a long time ago, but these days, more and more efficient appliances are available. In fact, the GE or Samsung or what have you, they will advertise they're required to show to the consumer the expected energy use before, at least in the products that are sold in the United States. And I hope the same is true in India, that every appliance that you buy needs to have some minimum efficiency rating. So what I'm saying is that in every aspect of our use, using conservation technology is very critical, whether it's lighting use or appliance energy use, or whether air conditioning use or HVAC use. There's a need for all of us to use less so that you can see the complexities of developing a new energy source, so that we impose less on the environment, less on the need for generating resources. Who else can help in this process? Truly, the governments and agencies need to plan and need to execute well, because it's not just consumers who are responsible. It's not just manufacturers who are responsible. The government and agencies need to have processes in place, regulations in place, permitting processes in place, so that when new projects are developed, new buildings are developed, they're developed well, they're planned well. Otherwise, if there's no policing, it's human behavior to build it any which way you please. And unfortunately, that has an impact on just overall society. So I wanted to suggest to you, as part of the closing discussion here, is that while there is great opportunity for renewable energy, it is also important for all of us to not forget the very basic essence, which is conservation. So I think with that, I'm pretty much done with whatever little I know about the whole topic. And so I'll be happy to take on any questions. Yeah, so it is an economic trade-off, right? So in theory, you could say that, well, we design a structure for speed of X. What happens if the structure is going to be, how is the structure going to be impacted if we get hit with a major wind storm or hurricane that is much more than, unfortunately, there is no easy answer to that. when structural engineers design, remember again, we have to think about different things here, right? The permitting agencies will essentially create a regulation that says that when you design a project today in 2020, in this location, the current standards are 150 miles per hour, right? And that's based on published, building standards and all that. It does not mean that the structural engineer can limit himself to 150 miles per hour. He could evaluate based on a factor of safety that says, okay, although the regulation is based on 150 miles per hour, I will use my discretion, assuming obviously it is a implication on the funding. I'll use my discretion to provide a factor of safety, because that's purely a decision that between the engineer and the developer. Because so long as the developer is willing to pay for it, engineer can design some superstructure. But at some point, we have to make the call, right? I mean, you cannot make anything indefinitely bulletproof. There's always a risk involved. And so long as you make a reasonable decision about what the factor of safety should be, that should be adequate. So in your case, you're saying that, so if your question is if a PV project installed in the mid-2000s with 100-year history of wind pattern could not have accommodated for the weather we are seeing today. That's very true. So that's where I would say that based on what we know today, that's all we can decide. Based on what we know today, there are two things we must meet. One is meet the current regulation. And two, to the extent you can substantiate and justify, you could put in a factor of safety. That would be my answer.
But I want to ask a couple of things, Jairam, which I have experienced here. One of our neighbors installed the rooftop residential PV, and the idea was to sell back the unutilized or overproduction of the power to the government grid. And this has become a cesspit because the government, even though it's a small state like Goa, they have actually not put the system in place properly. And this has created a lot of problem with the consumers. And the dual metering system, which I'm sure you understand, is flowing from the grid to the house and then back. They have not managed to sort this out yet. So unfortunately, a lot of people have invested in systems based on the assumption that this would happen and they would maybe even be able to get back the amount of investment that they've made, and it's all gone down the toilet. Similarly, in the industry, this is also happening where investors have taken technology, maybe say 5 years ago, rate of X amount, and now the prices have dropped because of the Chinese, as you said, coming into the market with lower and lower priced products. And they had contracted with the government at a certain price. Now the government is turning around and saying that, sorry, we can't buy at that price anymore because the market price is different, even though they have actually executed agreement with those people. So all this is tied up in tangled litigations.
Yeah, so the good thing here is that fortunately in America, if I am a consumer, I put in a PV, the utilities are required. In this case, whether it's LADWP or SoCal Edison or PG&E, they are required to bank the energy. So let's say I got a 4 kilowatt system on my house and I'm only using 1 kilowatt. So 3 kilowatt gets banked to the utility. Now over entire period, so long as my total consumption and total generation match, I can use the utility as a bank. So I'm protected as a consumer in this climate. So there is no risk. So a lot of the projects going on here in California and in the United States depend on the ability to bank, which is a great thing. So this is where I meant, this is where the policymakers, this is the responsibility of the policymakers to make sure people's interests are protected. So what you're telling me describes to me the failure of the policymaker, failure of the government to place the required incentives in place. Mm-hmm. Now, your only other option in this case, if you cannot depend on the government, unfortunately, your only option is to have a battery storage as part of the house, as part of the investment, where you can be completely self-contained. When you have excess power, you store it in the battery. When you need it, discharge from the battery. And sizing is important, right? So you need to be able to predict, you need to be able to say, look, if I'm using only X kilowatt in my house, and Y amount of energy over an entire year, so you need to make sure the sizing is not excessive, right? That's your responsibility as a developer. So I mean, it's sad that it's very sad that the policymakers have not realized the importance of uh, building confidence and building trust with consumers to make it happen. Right? It's very sad, but that's what do you do? They can't control.
It's a major
But anyway,
deterrent because even people who want to get into the sector will not will not like to get. Another thing is, I think a major issue is, as you said, transmission is the major cost, major infrastructure, major funding required for that. And as you are aware, most of the power generated in India, even now, is state. It's all state owned. Private operators are very, very few and far between. And we as consumers are actually not paying the actual cost of power generation. And I think that's very simple because at the end of the day, if we were to pay the real cost, we would not be able to afford it. So everything is subsidized to a very big amount in India, including water. And as a result of this, obviously, we are becoming very complacent, and we don't worry about wastage or what we are actually consuming. And this is a major problem, even in electricity, even though today prices have gone up quite a lot.
Yeah, I think exactly. So I think one has to be realistic. I mean, to some extent, subsidies okay because sometimes subsidies provided to help build a project. I can see subsidy helping in those areas, but when it comes to commodity like water or basic gas, electricity, I think one has to be realistic in the pricing. Otherwise, in fact, one thing that utilities do here in US is that when you know that it is expensive to produce power during a certain peak time, they automatically increase the price during the time to discourage the customer from using power during that peak time. See, that's a standard, it's called time of day pricing. And I don't know whether that's there in India or not for consumers, but here there is time of day pricing, not only just on energy, but on demand. So for example, if you use 10 kW at noon, that's far more expensive than using 10 kW at nighttime, right? So there are price signals that utilities can send to consumers about so that to encourage the consumer behavior in the right way. So this way, I think the utilities and government need to really work together. It's not a one-man job. It's really a concerted effort. Okay, so the next question, of course, your biggest challenge, I think, from what I'm hearing, is that you truly need in India a very strong and a very focused representation in the public sector, in the government. If the government is, really they need to take the leadership. And a lot of what has happened in the United States because the government took leadership. Of course, the developers in the private sector was helping with technology and everything else, but the government really is is in a commanding position. And it's so they need to take the leadership in making sure that the right environment exists for developers to build. That's really their responsibility. That's how, I mean, they cannot be placing stumbling block, but they should rather be thinking about what is the right environment for development to occur in a reasonable way. Then things will take off because entrepreneurs can go really fast. It's just that they need a proper environment and proper policy making. And I think that's where the biggest lesson is. I think the government sector in India should look at how other governments, whether it's the United States or Germany, have formulated policies to help development. If that's done, things will take off. That's my opinion. The thing about China is that, I mean, God knows what they do, but it looks like no matter what product they take on, they can do the mass production so inexpensively that the world is pretty much depending on them. Well, from T-shirts to silicon cells, we're depending on China these days. And along with came the, various other complications as well. But yeah, I don't have an answer to that one.
Remember reading the latest statistic that China is currently taking care of 45% of global manufacturing demand in everything. This is a question which will always be open.
Impossible to compete with the pricing. It just
that's correct. Yeah.
Impossible.
Yeah. All right, great. That was a fantastic session, Jairam. Thank you so much for taking the time. Thanks a lot for that. Thanks, guys. Good night.